While reading some of the comments in the previous videos, I saw a request to analyze this scenario where we have the internet that I am simulating here with this router and with this loopback that has this IP address. That this is a well-known IP address with this 8.8.8.8. And then we have an enterprise that is receiving an IP address through DHCP. And then we have two VRFs. So what we want to achieve with this lab is let these two PCs that belong to these two VRFs to gain access to the internet. So what we will need to do will be leaking the default route from the global routing table into each VRF, and then do some nathing, some network address relation. And actually it will be a port address relation in order to let these two devices gain access to this IP address. So let's configure the lab. Notice that we are going to use public IP addressing here because we are trying to simulate the internet, and we are going to use private IP addressing for each one of the VRFs. So let's bring the console here and let's configure first the internet part of the lab. So let's go to the loopback, then the IP address 8.8.8, and then let's go for interface gigabit 00, and then we're going to set up a public IP address, for instance this one, and then let's set up this router as a DHCP server. Let's do the only thing we have to do is creating a pool. Let's say customers, and then we are going to provide IP addresses within the realm. And then the domain name could be mylab.com, and then DNS server, and then the default router for this pool will be myself, which is this IP address. Okay. Okay, so let's go to the ISP router. We're going to configure this one now. So this router is going to get a DHCP IP address. Let's see, gigabit 00 will be IP address DHCP. Now shoot down. Then let's see. Show IP interface brief. I have received this IP address already, and given it is DHCP, I should have now a default route. This default route was created on the fly, given we have just received an IP address from the DHCP server. So notice that this is created on the fly. I didn't create this this static IP route. It is created on the fly. So now what we have to do is to create the two VRFs. So let's go and do that. VRF definition, customer A, or route distinguisher. It can be wherever because it is VRF Lite. And then address family IPv4. That's it. Then customer B, route distinguisher, whatever. And that's it. Now let's go and configure the interfaces. Interface according to the map. Gigabit 10, customer A, gigabit 20, customer B. VRF forwarding, customer A, IP address 1.1. Now shoot. Now for the other interface, customer B, the IP address is 2.1. Now shoot. And let's see the PC. I have configured here the PC IP address 1.2. This is 2.2. So now I must be able to ping my default gateway here. Okay, my default gateway on this side is 2.1. Okay, so far so good. So, but what if I want to ping the internet, or if I want to reach the internet? Not lock there. So we have to do several things here. Remember that we're going to use BGP in this case. So remember that BGP is my friend, and BGP is going to allow me to move networks or leak networks between the global routing table and the VRF. So if I examine my BGP rev, there is nothing there. It is not even active. So let's configure BGP. Remember that BGP is your friend here. And then for the address family IPv4, I'm going to redistribute connected, for instance. After doing that, if I examine my rev, I'm going to see that I am going to export or this particular network into the BGP rev. But that is not enough. It is taking a while. So that is not enough. I have to also leak or make sure that this I'm sorry, I have to make sure to have the prefix 0.0.0.0/0 into the BGP realm. So in this case, I have already injected into BGP my one IP address, my one prefix. So let's import also the default route. So let's go to address family and then let's issue this command. So when issuing that command, I should be able to let BGP be aware of the existence of a default route. So there it is now. So now that these two prefix exist in the BGP rev, now I can do the leaking. So let's prepare first the access list. For instance, access list number 1, permit 0.0.0.0. Oops. And then I can do also the one IP address. For instance, this one. And then I'm going to create a route map. I'm going to call it from global to VRF. I'm going to permit that, and I'm going to do a match IP address 1. And then I'm going to link this route map into my VRFs. So I will have to go into VRF configuration mode, VRF definition for customer A, and then inside address family IPv4, I will have to do an import IPv4 unicast map this name, and then I will have to do the same for the other customer. Okay, after doing that, if I issue show IP route VRF customer A, I should see these routes at some point. Let me see if everything is correct. This is my VRF. This is my other VRF from global to VRF, and then from global from VRF, I am doing a permit that will match this, and this is the access list. Okay, now it takes a little bit. It is not instant, but now we can see that we have a default route imported with VGP inside the VRF. So let's see customer VRF. We also have a default route now. Let's do the dummy static route, IP route 10, and that is reachable through gigabit 10. And this other dummy static route goes to gigabit 20. And then if I issue show IP route, then I know where this destination lives. This destination lives at gigabit 10, and this destination lives at gigabit 20. That is not enough. Let's see what my ping does. It is really not working. It is not telling me that it is unreachable. It is just not. It is not providing me the router error has unreachable, but we still cannot reach the internet. So we need to set up NAT here. So let's establish that my one IP address gigabit 00 is my IP NAT outside, and then my interface gigabit 10 is my IP NAT inside, and that will happen for my 20 as well. And let's create an access list that will let me know which IP addresses are allowed to get NAT it. So for instance, IP access list, I'm going to create NAT for VRF customer A, and I'm going to permit IP the segment 10, and then I'm going to do the same for the other VRF, where I am allowing this prefix to get NATed, and then we are going to do an IP NAT inside source list NAT VRFA interface gigabit 00 VRF customer A overload. And I'm going to do the same for the other VRF. IP NAT inside source list. Oops, there is an error here. Let me correct this. Okay, for the first VRF, we are going to have to enter IP NAT inside source list NAT VRFA, which is this access list. We are going to overload interface gigabit 00, and we are going to bound this NAT to the VRF customer A. And the other command will be IP NAT inside source list VRF B, which is the other access list. And then we are going to use gigabit 00 VRF, and we are going to bind this NAT to customer B VRF. So now we have our NAT translations, VRF, customer A, customer B, nothing. Let's try to ping this, and we can ping it because we are now doing NAT. Let's ping the internet from the other PC. We can see that ping with the other command, which is show IP NAT translations VRF customer B and customer A. So that will be the way to do it. Let's do a summary here. We are going to have to import with a route map into each VRF these networks. The most important network here is the default route. So with this, we are going to import the leak, the default route into the VRFs. And that route comes from the global routing table. How do I do that? With the help of BGP. BGP is my friend here, and I'm going to let BGP know what prefix do I have. I move my prefix from my global routing table into the BGP rev, so BGP can help me move these prefixes into the VRFs. And then I will have to do some NAT in here with the help of this access list. And then I have to create this dummy route. So my routing tables will look like this. This is my global routing table. I have a default route. This is my VRF routing table. I have leaked the default route here. And then I'm doing NAT to do the rest of the job. Let's ping again. Remember that these NATs exist for a certain amount of time, and there are some times where you will run out of NAT space, so to speak, because you are having too many local area network users that are using your NAT, and then this NAT can only provide so much NAT space, so to speak, for your users. So if you have too many users, you might want to reduce the time that this NAT operation is allowed per user. As you can see, if the user is not using this NAT, eventually it is going to, these entries are going to get erased, and another user can use these resources. But that is a matter of another session. That's it.